accidentally knock over a half-liter of acetone cleaning solution. The liquid splatters onto a working hot plate. Instant fire. What do? You act quickly, relying on common sense and a thorough understanding of your lab's emergency plan. Step-by-step procedures you know inside and out. Incidents occur no matter how careful we are. When they do, we have no choice but to deal with them. These are often the critical moments when lives and property can be at stake, so you have to know the correct course of action. This means how to clean up a toxic substance to limit the effects of a spill, or pulling a fire extinguisher off the wall to combat a fire. Or it may simply mean sounding an alarm and leaving the area as quickly as possible. To help you deal with these situations, your laboratory has developed an emergency plan, which takes into account the types of incidents you could face. There may be sections on chemical spills and fires, as well as more unusual hazards like radiation or biological exposure. Natural disasters such as earthquakes, floods, and tornadoes will also be addressed. You need to get a copy of the plan and read it. There are lots of things we need to be able to do if an emergency occurs. We need to know how to activate alarms and have to be able to distinguish between the signals for each type of emergency if we hear an alarm ourselves. We should know what to do to alert emergency personnel if we need their help. And we have to be fully aware of the evacuation routes for our work areas, as well as designated safe areas where personnel are to assemble after they evacuate. Facilities generally plan to fight large-scale emergencies in two ways, through local fire companies and internal emergency response teams. Your facility works closely with the fire company in determining how to handle any emergencies that may occur. So it's important that outside agencies like these be kept abreast of the types of procedures and hazardous substances your lab works with. Your facility may also have decided to assemble an internal emergency response team. If so, each member of this team will be trained regarding the potential situations they may face. When people think of emergencies, the first thing they think of is fire. While most laboratories are working to eliminate open flames, we still have good reason to fear a fire. The smallest flame can grow and spread quickly through a lab, flowing over benches and floors, branching out to attack other parts of the building. If we can get to a fire quickly enough, we can sometimes stop it in its tracks. But often, it's not that simple. In the case of a fire, there are 4 actions we need to focus on: helping the injured and warning others, attacking or confining the fire, alerting emergency services, and evacuating personnel. The order in which they're performed may vary, depending on the conditions at the time of the fire. But whatever you do, remember to never put yourself in danger. First, you should move any injured people out of harm's way and alert anyone else who's in the area. If lives are threatened, render first aid in a safe zone and send for assistance. Medical emergencies call for skill and quick thinking, so you should have knowledge of basic first aid and CPR. Next, you need to act quickly to determine whether you can safely fight the fire. If you think you can fight the fire without putting yourself in danger, remember, the quicker you act, the easier a fire is to put out and the less damage it will cause. In fighting a fire extinguisher is most often the first line of attack. There are 4 types of extinguishers that are normally used in labs. They correspond to the 4 most common classes of fires. Class A fires involve ordinary combustible solids, such as paper, wood, rubber, and textiles. Class B fires are fueled by flammable solvents and petroleum hydrocarbons, things like oil and grease. Class C fires involve energized electrical equipment. Class D fires are unusual in most labs. They're fueled by combustible or reactive metals such as sodium and potassium, or metal hydrides and organometallics. When you're fighting a fire, you need to make sure you're using an extinguisher that's rated for the class of fire you have on your hands. Most laboratories have ABC extinguishers, but check the label to be sure. When using an extinguisher, you should follow the pass system. First, pull the pin. Next, aim the extinguisher at the base of the fire. Then, squeeze the trigger. Finally, sweep the area with the spray. Never put yourself in danger when fighting a fire. Make sure you have an escape route in case it gets out of control. If you have any doubts that you can stop a fire, take a different approach. Work to confine the flames as best you can. For instance, if the fire is in a hood, pull down the sash. Evacuate everyone from the immediate area, shutting the doors behind you. This will help prevent the spread of flames as well as any toxic gases and vapors. Once you've moved people out of the area, the next thing you need to do is alert emergency services. Who you should call is outlined in your emergency plan and should be posted somewhere in the area. Make the call from a safe place. Give the location and type of emergency. Initiating total evacuation procedures is the last thing on the list. Remember to hit the alarm system and follow posted evacuation instructions. Assemble outside the building at your lab's designated meeting place. The most common injury suffered during lab fires is burns. These often occur when a person's clothing ignites and the flames aren't extinguished quickly. If someone is on fire, don't let them run. Drop them down to the floor. Snuff out the flames by rolling the victim, or use a fire blanket to smother the flames if there's one available. Some burns can be caused by chemicals that have ignited in a fire. When this is the case, victims may also need to be treated for chemical exposure. Be prepared to tell medical professionals about any chemicals that are involved in an injury. Fire can also result from the explosion of shock-sensitive materials. For instance, picric acid and ethyl ether can develop peroxides over time, making them highly unstable. Shaking their containers or even unscrewing the caps can have explosive results. Expired containers of these types of materials should be treated very cautiously. Alert your supervisor immediately if you find a problematic can or bottle. They'll notify your facility's disposal team, who will evacuate the area and remove the substance. If an explosion does occur in your lab, you should immediately turn off all heating devices and stop any reactions in progress. This will help prevent a fire or more explosions. Your laboratory's emergency plan also addresses chemical spills. If a spill occurs, you need to take steps to protect yourself and other lab personnel. Protecting property is the last priority. The actions you should take depend on several things: the location of the release, the quantities of spilled materials, the properties of the materials, both chemical and physical, any hazardous qualities they may have, and the personal protective equipment that should be worn to perform the cleanup safely. Before handling any substance, you should read its material safety data sheet. Effective emergency response begins with your knowledge of the spilled material. You also need to know where to go find a spill cleanup kit. These should be positioned at strategic locations and will contain the necessary supplies to clean up the types and quantities of spilled chemicals you may have to deal with. There are a number of standard procedures to follow in the event of any hazardous spill. First, notify everyone in the area. Evacuate all non-essential personnel. If the spilled chemical poses a flammability hazard, turn off all sources of heat and potential ignition. You may also need to confine vapors from the spill by closing the doors to your work area. And don't forget to mark them. Only workers trained in emergencies may enter a spill area. In some cases, building ventilation systems may need to be shut down to prevent vapors from spreading. So you need to notify your supervisor and safety personnel when spills are of a volatile nature. If you're part of your facility's spill cleanup team, there are a number of other steps you'll need to take. First, determine if you'll need to wear a respirator to work in the spill area, and if so, what type it should be. You may be okay entering the area with an air purifying unit. Run a fast safety check before putting one on. Look for cracks or tears and do a quick fit test. Remember, air purifying respirators are only effective when they have the correct filter cartridges. They must be rated to safely handle the type and concentration of toxic vapor in the air. So make sure your respirator is cartridged appropriately. Some situations may be so dangerous that a self-contained breathing apparatus is required. But never use an SCBA unless you've been properly trained. Once you've determined if a respirator is necessary, assemble all the materials you'll need to contain and clean up the spill. You may want to quickly consult the MSDS again to refresh your memory. Pay particular attention to other personal protective equipment and clothing that may be required. As you work to contain the spill, use absorbent pillows as much as possible to keep hazardous liquids from flowing into other areas. The larger the spill gets, the more things there are at risk. To take up small spills of inorganic acids or bases, use a neutralizing agent or an absorbent mixture such as soda ash or specially designed spill pillows that incorporate these types of materials. Other substances may be soaked up with paper towels or vermiculite. Double check the MSDS to be sure. Remember though, most vermiculites don't keep toxic and flammable vapors from rising into the air. However, many activated carbon absorbents do. So choose your cleanup materials accordingly. Ask your supervisor if you have questions. Dispose of all waste materials in approved containers for pickup. Once the lab cleanup is completed, you need to check the air quality to see whether people can safely return. All work areas involved in the spill must be decontaminated, and all tools and equipment should be decontaminated or disposed of as well. You should also turn in a report to your supervisor describing the incident and its cleanup. These reports help with future planning. One other thing you need to know when you're working in a lab is what to do if you're personally affected by a chemical spill. If you're splashed by a hazardous chemical, call out for help and get to a safety shower or eye wash station, depending on the area of your body that was splashed. If the chemical made it through your clothing and came into contact with your body, you'll have to shower. Soak your clothing all the way through, carefully removing all PPE. It normally requires 2 helpers to provide the needed assistance. You need to strip down to at least your underwear. Forget modesty. We're talking about your health. Remember to take off your shoes and socks too. After an initial deluge, you can go to a more private area to remove the rest of your clothing and finish the showering process. The entire time underwater must be no less than 15 minutes. The people that help with your shower may need to decontaminate as well. If you're splashed in the eyes, speed is especially important. Chemical splashes in the eye are very dangerous. Here you should use an eye wash station, holding the injured eye open within the water stream for 15 minutes. This 15 minutes is very important. Water both helps to dilute the substance that's in the eye and wash it away. You'll need at least that much time to make sure your eye is free of the chemical or that it's diluted enough so that it won't hurt you. In many emergency situations, first aid can mean the difference between life and death. If someone is injured, call for medical help as quickly as possible. Keep the victim calm. Don't move them unless they're in danger of further harm. Remember, first aid is a temporary measure to keep things from getting worse. Receiving prompt follow-up medical attention is imperative. If an emergency occurs in your lab, you need to be prepared to act. Let's review what you can do. Alert the people around you to the situation. Assist anyone who needs help, and if possible, remove them from the area. Decide whether you can deal with the problem yourself. If you can't, take steps to isolate it and call emergency services. And always sound the alarm for evacuation so others will know to leave the area. No matter what we do, emergencies can occur. But by knowing how to react, we can often limit any damage or injuries, sometimes even save a life.